Bonsoir à tout le monde. Je vous souhaite toutes et tous, les amis et membres de la société et de la branche, et particulièrement à notre invité distingué, Chair Fox, un accueil très chaleureux. A warm welcome to you, our friends and members of the Society and the branch, and especially to our distinguished guest, Chair Fox, of whom we will hear more very soon. My name's Andrew Dorr, and I'm the Secretary and Vice President of the branch. Ceci est un très brefage avant le vol. I will take up your time just long enough to tell you what's going to happen here. L'événement se déroulera en anglais, toutefois il y aura une période de questions où vous pourrez vous sentir libre de poser toute question en français. In a few seconds I'll sit down and our branch chair, Dr. John Maris, will introduce to you the Society, the branch and the Assad Kotaite lecture. Then it will be the turn of our UK President to address you from London, following which my colleague and Speaker Selection Committee member Valeria Morginova will introduce our distinguished guest. We will then hear the address for which we've all come. The question period will follow. Finally, my other colleague and Speaker Selection Committee member Christophe Laurent will express the branch's thanks to Chair Fox. With that, I'll pass the baton to Dr. Maris and wish you all an informative and enjoyable evening.
Thank you. Some technical.
So we have to redo it.
So you've unplugged everything, no one will hear the rest of this. So good evening, everyone. Bonsoir tout le monde. You're here to see Chairman Fox here, not to listen to me, but you're stuck with me for the next few minutes. So my apologies for that. And the reason I'm going to talk is to tell you who the Royal Aeronautical Society is, who the Montreal branch is, and a little bit about the lecture that we are celebrating, that we do every year near Aviation Day. So as soon as we are in business. There we go. Can you make that full screen so I can? There, perfect. And the magic button is that one?
Yes, sir.
All right. So let's start with who is the Royal Aeronautical Society? And it is simply the oldest aeronautical society in the world. And here's a picture of its headquarters. It has 24,000 odd members, affiliates all over the world. We support the development of standards, distribution of standards, education, specialist information. You'll see what we have in terms of working groups momentarily. Outside of Quebec, they can accredit engineers. I would have to wash my mouth out in Quebec because, of course, they can't in Quebec. Wearing my engineer's ring, so I can say that. And we award scholarships and bursaries and medals for various functions that people have performed that the Society recognizes, as I just said. And it's also a charity. It's a charity that's recognized worldwide. We are not a charitable branch. We are a not-for-profit branch, which is similar but not exactly the same. So a little bit about us. Sorry, about the specialist groups. So if you have an interest in air or space, there's a specialist group that does something for you. Aerodynamics, medicine, law, and so on, and so on, and so on. They consult worldwide, and it's open to you if you're a member to belong to one of these groups, contribute to these groups, help generate standards, and so on. And as you can see, if you can't find your spot in aviation here, probably you aren't in aviation at all. I'm going very, very fast. This is not an education. There's no exam. It's just to give you a perspective of who we are and what we do. The Society generates these aerospace recommended practices, of which there's a sampling. And again, this is the output typically of the groups that we've just seen. There are publications. There's the journal that comes out monthly, the aeronautical journal that we get, and there are also peer-reviewed articles that come out on any number of subjects. The largest, I believe, aeronautical library in the world belongs to the Society, and we all have access to it. So it's a place that if you happen to have the chance to get over and visit, I would strongly recommend. And now I'm going to talk a little bit about some of the functions that the Society believes in and that our president will talk about momentarily. This is one of my favorites. Looking around the room, how did we do here? We probably beat the average in aerospace in terms of ladies to men in terms of the ratio, because it's appalling, frankly. So 51% of us workers are ladies, and 8% of professional engineers are ladies. So we have to do something about that, and the Royal Aeronautical Society has a specific function and group that is endeavoring to fix that. It also tries to support women that are already in the workforce. Those of you that are in the workforce can relate to the difficulties that can have. It's still a glass ceiling profession, and you need all the help you can get. And it's one of my personal mandates for our branch to try and equalize as best we can. And there's a link here that you can find. I'll be happy to provide this to anyone that wants to follow up. It's a little confusing because what I see here is not what's on the board. It's a couple ahead. So now let's talk about our branch for a moment. Yes, we were founded in 2003. As you probably know, this is one of the world's largest aerospace hubs. A lot of people are surprised to find that. It depends how you measure it. We're number 4, 5, 6, 7 in the world, but we're up there. A lot of people don't realize just how much aerospace has contributed to Canada and how much we have contributed to the world. What was the first thing that landed on the moon? Julie Payette would share this, that landed on the moon on Apollo 11. It was the Canadian-made DevTech landing pads on the lunar lander. Who was the third nation in space at all, with no caveats? It was us with the Alouette satellite. The Canadarm, you could not do anything with the space shuttle without the Canadarm basically putting it together. I happened to be the program manager for the space station Canadarm2 control stations. Couldn't have assembled the space station without an arm that could fling a space shuttle around the place. And that's homegrown. Probably the most significant simulator company in the world, CAE, is just down the road. And I've got to be careful what I say and don't say, because I'll miss someone and then I'll feel terrible. But Bombardier invented basically the phrase regional jet with its CRJs, and is one of the most profound in that marketplace. Pratt & Whitney, do I need to say any more? The small gas turbine Pratt & Whitney are synonymous, and that's just down the road. Rolls-Royce is here, ICAO is here, IATA is here, and you can throw a rock to any of these places from where we're standing. Okay, so a lot of people don't realize that. So we represent that group, and our mission is very straightforward. It's to inspire advancement in aerospace knowledge. This one, because actually this is quite difficult when it's not the same. We have a vision, which is actually multifaceted, but we network, we stimulate, and we mentor. Guess what? That's what we're doing right now. We give lectures. The one on the bottom was a lecture I gave, and the one on the top is a group that I work with very closely. So what other things do we do? We have the NE-RO lecture competition that has been basically forwarded by Valeria. We have Cool Aeronautics, also this branch has been running those outreaches. We have the Young Persons Committee, YPN. We have the Branches Committee, which Fadi, who was here just a moment ago, actually visited France on our ticket, basically, or half our ticket, to represent us to the rest of the society. And we have two partners with the Canadian Aeronautics and Space Institute and the American Institute of Aeronautics and Astronautics, who we co-lecture with. We have the named lectures, of which you are about to become subject. So let's talk briefly about those. Every 3 years, we have the Nancy Bird Walton Lecture, which is an Australian, it comes from the Australian honoring pioneering leaders from their sector. And look at who we've had. Richard de Crespigny, who was the commander of the A380 that blew itself to pieces and got it back on the ground in one piece, a truly miraculous piece of airmanship. And then we had Captain Lisa Norman that broke down so many barriers in her industry that it was an incredible, incredible presentation. And then today's lecture, the Assad Kotaite keynote lecture. It's our lecture of the year, if you will. I won't go through all the lectures we've had, but it is, sorry. Oh, sorry, yes, thank you. Valeria's main job is to keep me straight, so she's full-time busy doing that. This has this very helpful, this is what you would see if you had pressed the button 2 more times. That's what it shows on here. You might want to be aware of that. But anyway, the Assad Kotaite lecture, I'm going to talk about Dr. Assad Kotaite in just a moment. And he was, in fact, our first president. We don't currently have another president. We don't have anyone senior enough and acclaimed enough to be the president of our group. You have just a chairman who crawled in and got that role. But Assad Kotaite was our first president. And here is Dr. Kotaite. I had the pleasure of meeting him. Of course, he was a fellow of the Society, the first ever recipient of the Global Aviation Leadership Award. He basically transformed ICAO and has won more awards and done more for our international community than anyone else we could mention. And he is our patron. And in fact, we used to hold this lecture at ICAO until we couldn't afford to anymore. So we're here doing this venue, but this was very much in honor of Dr. Assad Kotaite. So here we are at the Assad Kotaite lecture. My last note here, anyone here that's a student, it's free to join the society. Why wouldn't you want to do it? Why wouldn't you want to do it? Once you are out of school and you have to pay, then you can make a decision about whether the dues and what you can do with the society. But we as a branch welcome you whether you're a member or not. There are volunteer positions. It's a very active branch. We can go to places like CAE. We can have interesting lectures. We sponsor people to go to Europe. We have awards for competitions. So it's actually a really decent place to belong if you like aerospace. So with that, I just want to give a couple of words of thanks, and then I'll hand this over. The committee that, first of all, elected our guest speaker for today is very active for about a year to come up with this. It's not we don't pick names out of a hat. It's quite an exhaustive selection process with candidates, and we've had the head of NASA. We've had all kinds of incredibly high-powered people here. So it's a very competitive thing, and it's a real honor for us to have our guests, but it's also a big deal to get picked to be here. So congratulations, Catherine, for that. That's so the committee's been extremely busy, and Christophe, Chris Lyle, Andrew, and Valeria, and have I missed anyone? That's it. Thank you so much. And the committee in general that keeps me straight. I wave my arms around and ask things to happen, but actually they do all the hard work. So my sincere appreciation to the committee who was well represented here tonight. So I've used up my time, more or less. I'll be happy to speak to anyone after the question period. If you want to know more about the society or our branch or any of the branch members, would be good to do that. So the next thing, which I don't have the technology to do, is to get a message directly from our president in the United Kingdom. Because of the hour, we had him record it a little earlier, because it's kind of dark 30 right now. And it gives you an idea where we sit, that the president of the Royal Aeronautics Society took the time to give us a presentation, a personalized presentation. And a couple of months ago, we had the chief executive officer to ourselves for the better part of a day. So that's where we stand as a branch. Thank you for your time. You're all very welcome, and I hope you enjoy this fabulous evening.
Hello, Montreal. Bonjour. For those of you who don't know me, I'm Pete Round. I am the current president of the Royal Aeronautical Society, and I want to thank you very much for giving me this opportunity to send a message from London on the occasion of the 19th Assad Kotaite lecture. I know you've got an interesting evening ahead, and I don't want to take up too much of your time. But if you'll just bear with me for a moment, I'll talk about a couple of things which are really important to me during my presidency. There are three key themes. The first is young people and early careers. Currently, our sector is suffering an acute skills shortage. We're not alone in this, and we're in competition with almost every other industry to get the brightest and the best engineers. We will continue to work hard to get people right from school, college, and older people to come back and join our sector. And I'm glad that you are helping us in that process. The second theme is that I want the society to be the go-to place for learned advice. We do that by maintaining the quality of our output and maintaining our relevance. This allows us to influence industry, academia, and government. The third theme was a governance review. The Society's governance was very complicated and indeed didn't include a vote for every member. We're changing that, and there's another video on this theme which I hope you'll get time to watch. Most importantly though is the Royal Aeronautical Society is a worldwide society. Aerospace is a worldwide industry and we have to reflect that. I'm glad to say that our relationship across the globe with our branches is excellent, and part of that is this little introduction today, that as we all work together in a global business with a global society. My last pleasure is to welcome Kathy Fox, who's speaking to you today. I know there's another introduction following me, so I won't go beyond that other than to say we are delighted that the Royal Aeronautical Society can still attract speakers of such calibre, and I wish you the very best of luck with your talk.
Okay, good evening, everyone. I'm the Young Persons Network representative for the Montreal branch of the Royal Aeronautical Society, and it is my pleasure to introduce today's speaker, who I have the honor of being able to call my instructor. If I try to list all of her accomplishments, our room booking will end before we get to the actual lecture, so I have to be brief. Serving as chair of the Transportation Safety Board of Canada for 8 years now, Kathy Fox has done a lot in aviation and for aviation. It is fitting that today's event is held here at McGill because she graduated from this university 50 years ago with an undergraduate degree and later returned for her master's. Since flight training was too expensive to pursue while in university, some things never change, Kathy Fox joined the McGill Skydiving Club instead and went on to achieve much success in the field of sport parachuting. Later, after she learned to land the aircraft, she stopped jumping out of them. Kathy Fox joined Transport Canada to begin working as an air traffic controller and then transferred to NAV Canada along with the ATC function. There, she held various senior positions. After retiring from NAV Canada in 2007, she joined the Transportation Safety Board of Canada and in 2014 was appointed its chair. In parallel with her ATC career, Kathy Fox also pursued a flying career. She holds an ATPL and Class 1 flight instructor rating, and her more than 5,000 flying hours include instructing, flying charters through an air operator she founded, together with 2 other pilots and a mechanic, and being a Transport Canada pilot examiner. She continues to instruct part-time at the Rockley Flying Club, turning pilots such as myself into new instructors. Aside from her jobs, Kathy Fox has always been actively involved with various aviation organizations, not least with the 99s, where she has served in many positions. There is a group of the 99s that are here with us today, a few in person and even more so virtually. Her achievements and contributions to aviation have earned her inductions into 3 halls of fame and awards too numerous to mention. So I will stop there and ask you to please welcome Kathy Fox to give her presentation titled Evolving Approaches to Managing Safety and Investigating Accidents from Individual to Organizational Safety Management.
Figure that out. Well, good evening, bonsoir. Thank you very much for coming, and thank you very much for the invitation to present tonight. I have had the opportunity to attend an Assad Kotaite lecture before. I didn't think I'd be invited to provide the 19th, so thank you very much for this honor. I'm really glad to be here, and thank you for those of you attending in person and also for those of you attending online. It's especially special, as Valeria has mentioned, to be able to do it here at the McGill University campus, where I spent many years studying, where I earned 2 degrees. I was saying I used to walk up the street past the faculty club, I was never invited in at the time, up to the student union, which is actually where we started the McGill Skydiving Club back in the late 60s. So tonight what I'd like to do is share with you some of my experiences and the lessons that I've learned along the way, and how my perception, my thoughts about safety management and what can be done to reduce risk in the transportation system, how they've evolved along the way. And so I'm going to talk about my own thinking, how my own thinking is involved. I'm going to talk about some of the schools of accident causation theory, which basically underscored and underpinned the development of safety management systems in the aviation sector in Canada. I'm going to talk about some of the lessons I've learned with respect to hazard identification, safety reporting, and measuring safety performance. Then I'll change gears and talk a little bit about the TSB and how that underscores how we investigate accidents and incidents in this country. And finally talk about some of the emerging safety issues that I think we have to deal with. And while I'm going to focus this lecture on aviation, I think you'll find that much of what I say can be transferred to other safety critical industries, including nuclear power, the medical industry, and so on. So if I go back in time, my whole career, and Valeria aged me by saying that I graduated 50 years ago from McGill, it's true, but my whole career has been about practicing safety. You know, we talk about lawyers practicing law and doctors practicing medicine. Well, I feel like my whole career has been about practicing safety. And basically, before I joined the TSB, my first career was as an air traffic controller. I wanted to be a pilot, but there weren't very many female pilots in the day and I needed to work, so I joined air traffic control. And actually that was one of my first postings in 1974 at Setsill Tower. But as an air traffic controller, my responsibility was to make sure that aircraft didn't run into each other or into the ground, as well as to provide information that was necessary to pilots for the safety of flight, such as weather information and runway conditions and so on. And when I became an air traffic controller, I had the money and the time, so I learned to fly. And as a commercial pilot, I was responsible to transport people safely from point A to point B. And as an instructor, I teach the basics of safe flying so that other people can get their pilot's license or get their advanced ratings, like an instructor rating. And now in my current role as chair of the Transportation Safety Board, I work with the other board members to review accident investigations that have been conducted by our staff, to identify safety deficiencies, to find out what happened and why it happened. Why did the occurrence happen? Why did the accident happen? So that steps can be taken to reduce the risks going forward and prevent those accidents or those occurrences from happening again. So it may seem odd, but early in my career, I didn't think about what that word safety really meant. In fact, I was taught and I believed that as long as you follow standard operating procedures and you pay attention to what you're doing and you don't make any silly mistakes, and provided the equipment doesn't fail, then it's safe. And so that informed my thinking in a lot of the activities, whether I was flying a plane, or, and somebody asked me if I was going to talk about skydiving tonight, whether I was jumping onto the lower campus here in 1971 in honor of McGill's 150th anniversary at the young age of 18. My notions of risk those days were very different from what they would be today. And when I became director of the department or the division in Transport Canada that investigated air traffic control incidents and losses of separation, that informed my thinking. I thought we always tried to find out, well, did the controller not follow procedures or did they lose situational awareness? Does anybody know where situational awareness goes? Because some people have lost it along the way. We didn't really dig down to find out why. Why didn't they follow the procedure? Why did they lose situational awareness? And now the why is the most important question that we have to ask when we're looking at occurrences. When I was Director of Safety at NAV Canada, I was in charge of implementing a new program of corporate safety oversight for the then fully privatized air navigation system in Canada. And we had to develop policies and processes and practices to identify hazards and assess the risks, and then inform the managers of the company who were in the best position to take action to correct them. So this role as Director of Safety at NAV Canada really resulted in a major change, a major turning point for me in how I started to talk about safety and specifically talk about risk management. Does anybody think that aviation doesn't have risk? And you can't eliminate all of the risk or make it zero. But you can certainly reduce it. And so my thoughts changed as we started talking about more specifically about how do you manage risk. So I came to realize that safety doesn't mean zero risk, and that organizations have to balance competing priorities, including operational priorities and financial and environmental, just to name a few. So I often hear safety organizations or transportation organizations say that safety is their top priority. And I don't agree that that's necessarily their top priority. I would argue that customer service or return on investment is really their top priority, but that products and services have to be safe if you're going to remain in business, if they're going to avoid accidents and costly litigation, and also maintain competitive advantage and customer confidence. So I'm not alone in thinking this way, and case studies and accident investigations have frequently emphasized how organizational factors, such as the emphasis on productivity and cost control, can result in trade-offs, and how those trade-offs can inadvertently contribute to the circumstances that lead to an accident. And this concept was illustrated by a dynamic safety model that was developed by researcher Jens Rasmussen back in the 80s, which the TSB has referenced in a recent in-depth study we did into the safety of the air taxi sector in Canada, which actually has the highest number of fatal accidents and fatalities. Now, I think that most people have seen this model somewhere at some point, and that's, of course, the model that was developed by James Reason, called the Swiss cheese model. And that illustrates how the convergence of operational policies and management decisions and normal human errors, which sometimes people call unsafe operator acts, can converge. And if there's a breach in the safety defenses that are in the system, they can converge to create a window of opportunity for an accident to occur. So while this linear depiction may oversimplify the complex and the random events that actually occur and lead to accidents, I found that it was really helpful when I was at NAV Canada to explain to other departments in the company, such as finance and HR, that their policies and their practices could contribute to an accident. And so I think that it has its merits in that it does show that accidents, that a lot of people can contribute to setting up of an accident, or that in other words, safety is truly everybody's responsibility. Now, in 1998, NAV Canada commissioned a review by Dr. Ron Westrom. And Dr. Westrom is a sociologist or a sociology professor at Eastern Michigan University, to identify the desirable characteristics of organizations that effectively manage safety. Now, I'm not going to go through them. You can see them here on the slides. But it's interesting that over the years, there have been studies about high reliability organizations and effective safety management. And some of these characteristics are really what went into the development of safety management systems in Canada. So, and not only are they in use in aviation, but in other modes such as marine and rail. And Dr. Westrom also did a lot of work with respect to defining the spectrum of safety culture in organizations. Because effective safety management processes in and of themselves won't necessarily guarantee safety unless they are enshrined in a robust safety culture. So they have to go hand in hand, both processes and culture, in order to reduce risk in operations. And this is something that the TSB routinely looks at when we conduct our investigations. In other words, we look at how effectively an operator did or did not manage the safety risk in their operation. Now, some of my greatest insights came from studying under Dr. Sidney Decker. Dr. Decker was the Director of Research at the School of Aviation at Lund University, where I took my Master of Science in Human Factors and System Safety in 2009. And he maintains that safety is never the only goal. Safety is never the only goal, that organizations exist to provide goods and services and to make money, and that's okay. That people do their best to reconcile different goals within the organization simultaneously. For example, service delivery, cost effectiveness, and safety. That a system isn't automatically safe, that people create safety or practice safety at all levels of the organization, and that production pressures ultimately influence the safety trade-offs that organizations make. And this makes what was previously thought of as irregular or unsafe somehow normal or acceptable. And Decker goes on to say that human error isn't a cause of failure. Human error is the effect or symptom of deeper trouble. Human error is not random. It's systematically connected to features of people's tools, tasks, and the operating environment. I want to stop there for a second because I was once doing a news conference in Calgary following the release of a report that we'd done into the crash of a Citation jet in Kelowna. And we were talking about some of the issues and that happened there. But one of the reporters challenged me. He says, "Why won't you say human error?" And I said, because as soon as I say human error, that's the headline. And really what we have to look at is why that happened, because that pilot didn't get up and think, I'm going to have an accident today. So why did the pilot behave or do what he did? It's very important to get to the bottom of that. So it's important to think of it not just in the individual's terms, but also in the context of the organization, because it's the organization that creates the operating environment, that provides the tools and the training and the resources to do the job. And so the organizational commitment to safety has to permeate the day-to-day operation if it's to be truly meaningful and effective. And so this proactive identification of hazards in the system that can in fact lead people into errors, that can lead to bad outcomes, is why it's so important that we look at it from a hazard identification perspective. But identifying safety hazards isn't without its challenges. And one of the things that Dr. Decker talked about is that sometimes as companies evolve, as operations evolve, we change procedures, we change training. And without necessarily thinking about the impacts of that, that can inadvertently compromise safety by causing organizational drift. And he asked the question, why do safe systems fail? Why do they fail? So one factor he identified was this notion of drift into failure. And it's happening all the time in just about every organization. It doesn't mean it's going to lead every organization into having an accident, but it is happening. It's about slow and incremental movement of systems operations towards the edge of their safety envelope. Remember, I showed you that safety envelope with the boundaries, and I'm going to talk more about that. But it's always pushing an operation to those boundaries, either to be more cost effective or more productive. And so that can lead to organizational drift and can put reduce safety margins in the process. So pressures of scarcity and competition typically fuel the drift. And without knowledge of where those boundaries are, and it's not like you can see them, people don't see the drift until it's too late and something bad happens. So I'm going to give you an example that he used, and that was the crash of Air Alaska Flight 261, where the failure of a jack screw in the MD-80 aircraft trim system resulted in the aircraft losing control and crashing into the ocean off the coast of California with a loss of all 88 souls on board. So the NTSB investigation showed that the lubrication schedule for this jack screw increased from an interval of once every 300 to 350 flight hours to once every 8 months, which was about 2,550 hours. And then the jack screw recovered from the accident site revealed no evidence of having been lubricated, even at that interval, meaning it might have been more than 5,000 hours since that screw had last been greased. So from 300 to 350 up to almost 5,000 hours. So the question becomes, what if any risk assessment was ever done when they changed the lubrication schedule? And was it based on the incremental changes over time, or did it ever look back at the original certification when the aircraft was certified? So these are the sorts of things that we see in real life. And even when risk assessments are done, we're limited by our own imagination. People don't fully appreciate what can go wrong, how independent events can interact, the effects of proximity and common mode failures. And Boston College sociologist Diane Vaughan, and if you ever have the chance to read her book about the Challenger crash, I highly recommend it. She researched this phenomenon. She identified that our limited abilities to search for information and solutions to problems, combined with the influence of deadlines and the number of problems under examination at any one time, have to factor into the scope of risk assessment. So one of the things that we look at is the aspect of safety reporting, which is a key element of any safety management system. And it's important to have an internal safety reporting system, but the question is, what sort of event should be reportable? So traditionally, they've been events resulting in adverse outcomes, so accidents, where there's some damage, or people get hurt. But if you focus in, or if you narrow down the safety events that are reported, then it really deprives the organization of learning more about risks and hazards in the system. So by defining it too narrowly, an organization risks losing information about other types of events that indicate potential risks and vulnerabilities in the system. And that can lead to drift into failure. It can lead to accepting or normalizing shortcuts, which then become the norm, but which erode the safety margins. So if data on near misses, so-called near misses, isn't collected and analyzed, then opportunities are lost to prevent further adverse events from happening. But simply counting errors isn't good either. People don't like admitting errors, and if you try and count errors, often that drives it underground because people are afraid of retribution. And the other thing that happens is just because nobody reports errors and just because nobody reports events doesn't necessarily mean the system is safe. It may mean a number of other things. It may mean that people are afraid to report. It may mean that there's no good system for reporting, or that they don't know what to report or who to report to. So fear of retribution really hampers people's willingness to report, and non-punitive reporting systems have been demonstrated to bring a lot more information out that can help managers and safety departments better determine what are the hazards in the operation that can create risk, provided people feel that it's actually going to make a difference, that the reports that they make are not going to lead them to be punished, but also that people are going to take them seriously and do something about them. And research has shown that the main reasons why operators make reports stems from the realization that they could make a difference, particularly if they're reporting to a knowledgeable safety operations group, and if they can see, the improvements in the system. Now, you may not be aware, of course, the TSB has mandatory reporting of certain types of occurrences. which are under the TSB regulations, but we also have a confidential safety reporting program called Securitas. And anybody, anywhere, can report an unsafe condition or a hazard through Securitas, and we will look at it, take action. We could even do an investigation based on it. But the important thing is the identity of the reporter is held confidential and protected under our Act. Let's talk about culture a little bit, because I talked about culture earlier and you saw that progressive scale from sort of pathological, I'm just going to do the minimum to get by or try and not get caught, to sort of generative type generative type cultures. But when Transport Canada introduced the safety management systems for large scheduled carriers in this country, they believed that proactive safety management was the best way to improve the safety record in the country. That just relying on compliance with regulations wasn't enough, because you can never make a regulation for every scenario. The regulator can never think of every possible situation that can happen. And even James Reason was said to have said to somebody from Transport Canada once, if you put a Transport Canada inspector on every flight in this country, you will not eliminate accidents. There will still be accidents. So it really comes down to proactively identifying hazards, assessing the risks, and then mitigating them. But the only way that's going to work is if it's actually not just a bunch of manuals on a shelf, but rather it's an organic, it's an institutionalized, internalized set of processes that the company lives by, and that's where we get into the safety culture aspect of it. And Diane Vaught said, the work group culture contributes to decision making by becoming part of the view that individuals bring to their work. And in fact, even within an organization, and I'm sure you can think of your own organization, particularly if you're in a large one, you can have subcultures. So you can have, you know, a different culture in one part of the organization than you have in the other. So she wrote the book about the Challenger, but I'm going to talk about the loss of the Space Shuttle Columbia. And the U.S. Columbia Accident Investigation Board, which investigated the loss of the Space Shuttle Columbia in 2002, found that detrimental cultural traits and organizational practices were allowed to develop. Specifically, and I think these are the key criteria, that reliance on past success as a substitute for sound engineering practices. In other words, if you keep doing the same thing and nothing bad happens, it must be okay. Organizational barriers that prevented effective communication from safety critical information and stifled professional differences of opinion. And the evolution of an informal chain of command and decision-making processes that operated outside the organization's rules. So you can see here that, you know, a lot of the evolution of the theories of accident causation have started to look much deeper into the organizational culture than just looking at the technical or the operational factors that may have gone wrong. One quote that I like particularly, and I've lived it, and I'm sure some of you could say the same thing, and this was in the book called Normal Accidents by Charles Perrault. He warned of the risk of undesirable cultural traits that can form in an organization's management team, and he said, and I quote, "Managers come to believe their own rhetoric about safety first, because information indicating otherwise is suppressed for reasons of organizational politics." And that really resonated with me. As I mentioned, I studied under Sidney Dekker, and one of the questions he asked is, how do organizations respond to failure? How are safety and accountability balanced? And it's particularly relevant with the apparent increased tendency to litigate errors and criminalize human error. So his book, Just Culture, explores this, and he lists some of the characteristics, which you can see on the slide. But he says, when a professional mistake is put on trial, safety almost always suffers. Rather than investing in safety improvements, people in the organization or profession invest in defensive posturing. And I hope in the questions we can get into some of that, because there's always this notion of we want to find out what happened because we need to know why it happened so we can prevent it from happening again, but somebody else wants to take that information and sue or put somebody in prison. So how do you reconcile those conflicting goals? So rather than increasing the flow of safety-related information, legal action is just a way of cutting off that flow. So he advocates for a just culture that emphasizes understanding, which defines or draws the lines over, appropriate actions, offers support to those who've been involved in the occurrence, ensures safety is evaluated independently, and protects data from undue outside access, makes sure that everybody involved knows their rights and their responsibilities. And these traits of a just culture are how we increase accountability by increasing the information about the event and therefore increasing our understanding about why it happened. So, moving into the TSB, we are an independent federal agency. We report to Parliament through the President of the King's Privy Council. I still have to think about saying that. But we are independent, and our only mandate is to advance transportation safety by conducting investigations into air, rail, marine, and pipeline transportation modes in this country. A lot of people think we just do aviation, but we're multimodal, and we do those other modes as well. And when we investigate an accident, it's very clear in our legislation, it isn't our role to assign blame or determine civil or criminal liability. Now, this is a busy slide, and I'm not going to go through it, but I just want to show you that we have, because we've adopted a lot of the frameworks that I just mentioned, we adopted Reason's model of accident causation as a fundamental framework underlying our approach to accident investigation, because it represents the notion of multi-causality. No accident is ever caused by one reason. Not only did it represent multi-causality, but it also demonstrated that although investigators see human error as a last step in the accident sequence, in fact, it has to look deeper into the organizational context that allowed that human error to occur. So human error is merely seen as a starting point. So as I said, this is the methodology we use. It basically, in its most basic terms, is identify a sequence of events, what happened, look at the safety significant events, and then drill down. Why? Because it's only at understanding the whys that you can fix the issue. And then looking at the safety defenses that were existent, that were breached, or that weren't there, and that need to be put in place. And then in the 90s, Westrum's concepts were incorporated into the investigation methodology. And we have a guide for investigating for organizational and management factors. And our investigators are taught these notions of practical drift and normalization of deviance, and the need to understand an accident from the perspective, what we call it, inside the tunnel. Why did people do what they did at the time? Because it made sense to them, because they didn't wake up thinking, I want to have an accident. So how do all these come together? Well, I want to come back to this slide because really aviation is continuing to increase in complexity as the technology advances and as more and more aircraft fly. So the whole concept of boundaries, which is at the core of our study into the air taxi operation, is to show the blue dot is just that where you are today in the operation, and that blue dot moves around. But the point is that in order to continue to operate, those boundaries have to be economically viable, able to provide service, able to do the workload, and safety. And so for an operation to remain as safe as possible, it has to stay within those boundaries. But what happens when those boundaries move towards the center? In other words, the boundaries start crowding in, further restricting the safe space. Or alternatively, what happens when the pressures represented by those boundaries push the operation outside the safe operating margin? And the problem with this is you don't see them. They're not as easy to just put on a slide. So the MAX 8 is an example of this point that companies have to manage competing priorities, including financial pressures. So in an effort to improve the efficiency of the Boeing 737, Boeing changed the configuration of the aircraft and the resulting aircraft performance in ways that change its performance. And to compensate for the altered flight dynamics of the MAX 8, Boeing implemented the maneuvering characteristics augmentation system. But they did that in order to reduce or avoid significant extra training for the pilots who are already used to flying that type of aircraft. And so what we've learned since then, following the two accidents, the first one with Lion Air and the second one with Ethiopia Airlines, is that the pilots weren't aware of those systems or how to respond to them, or when it took over control of the aircraft, so to speak. So this leads us into the notion of automation. And we know that aircraft are becoming increasingly automated, and the assumptions made in the development of automated systems are an important part of how or if safety can be maintained. So I think the MAX 8 accidents illustrate the need for aircraft designers to think not just about aircraft performance and efficiency, but also about the end user, the flight crew, and how they're going to understand and interact with those systems. Because ultimately, automation can offer a lot of additional safety benefits by having more redundancies and more fail-safe systems. But if we don't think about it from the end user's perspective, then we can get into situations as we saw with the MAX. So earlier, I spoke of the difficulty in predicting possible risks to safety given the limitations of our imagination. However, SMS calls on all of us to make the most of the imagination as we attempt to identify the risks and find ways to mitigate those risks. And despite this difficulty, we need to think about the past as we move into the future. So another issue that's on the horizon, of course, is the proliferation of remotely piloted aircraft systems, or drones for short, which is increasing the risk of collisions with traditional aircraft. The TSB has already published one investigation involving a collision between a drone and a multi-engine turboprop aircraft on approach into Quebec City in 2017. We're currently conducting a second investigation into a collision between a police drone and a training aircraft that happened in 2021 at Bottenville Airport near Toronto. So part of the difficulty in understanding the risk is that the TSB doesn't really have reporting regulations for RPAS. And so now we're putting out guidance as to when these types of events, obviously a collision has to be reported, but when close calls should be reported. Because we don't know how many of these things are out there and how great the risk is in the system. So we know, though, that these are going to become increasingly used in the system, whether it's Amazon dropping off packages, whether it's the Europeans who are evaluating the viability of unmanned aircraft carriers. So there's a lot to think about as we move there. And moving into sort of the last point is that shifting from technology, I want to talk briefly about climate change. Now, I'm no expert on climate change, and it's certainly outside the mandate of the TSB, but we've seen hints about how our changing climate is impacting transportation safety. And the European heat wave of 2022 caused complications for all manner of transportation, and including a runway at London, in London, England, where the runway became so soft in the extreme heat that they had to close it effectively from being used by larger aircraft. We know these weather trends are going to accelerate and get worse, so it's important to consider how to proactively evaluate these types of risks and take measures in the future. Now, by our mandate, our investigations are reactive. We look at occurrences that have happened. We also evaluate data trends over time, and they can inform future investigations. But as the pace of change quickens, the more our understanding of the safety boundaries is going to lag the changes in the real world, with the potential for real world consequences. So, in closing, I just want to summarize with a few points that I think illustrates the evolution. And that is that adverse outcomes, accidents, arise from a complex interaction of organizational, technical, operational, human performance, and other factors. And they can interact in unpredictable ways. And that's going to require more sophisticated and sensitive risk assessment processes. That people at all levels of the organization create safety or not. It's not just the frontline people. That true accountability is about more than retribution. It's about more than blaming or retraining or firing or putting in jail or suing the people who were directly involved. It's about looking at, how we can learn from these events and prevent them from happening in future organizationally. That near misses are important learning opportunities, and they're free because nobody died. So we've got to find ways to amplify those weak signals that are out there that are telling us we have a problem in the system before it causes an accident. That accident investigations, for all we do, are at best constructions of what happened. We can't always figure it out because we don't have the data. The individuals involved didn't survive the accident. But we do have to think about why it made sense for them to do what they do or did in order to find out the ways to improve the system. And we have to do it without using judgmental language, without cherry picking the data to suit some theory, because we have the benefit of hindsight bias. And while it's that as we look towards the accidents of the future, external factors that we didn't think about before, like climate change, will have to be considered as we try and predict the accidents of the future before they happen. So in closing, I would really encourage you, and this is what I was trying to do with this, is to think, is to read widely, is to think about the things that we can do to reduce risk in the aviation system, to debate it, to discuss it with other subject matter experts, but not to jump to the conclusion. Every time I watch TV and there's been an accident and I hear the journalists say, it just happened. We still don't know what happened, and we don't know if it was human error or technical breakdown. Please don't accept that, because it takes time to figure out what happened if we're able to at all. And it's much deeper than just human error or technical breakdown. So on that note, I will end here and hopefully answer some of your questions. Thank you very much for your attention. Et merci beaucoup. Et j'espère de répondre à vos questions en anglais ou en français.